Hello everyone. Welcome to the presentation for the Data Science for the Common Good program here at UMass. Today we are going to talk about our collaboration with PVTA to implement data science techniques for improving their regional transport network. Team consists of Ian, Disha and I, Anushka. We are all CS graduate students at UMass. We worked under the guidance of Dr. Matthew Rattigan, who is a faculty member in our department. A little bit of background about PVTA. PVTA or Pioneer Valley Transit Authority is the largest regional transport system in Massachusetts. If you've ever been to Pioneer Valley in Western Mass, chances are that you have definitely taken a PVTA bus. Traditional public transit is easy to understand, but when it comes to low population density areas, implementing a fixed route bus service there could make it underutilized and also not a good investment. That is where microtransit comes in. It makes sure that there is increased access to transit while also taking care of the transit authority's budget. Microtransit is nothing but having smaller scale vehicles that run on demand. That way, you could increase the access to jobs and other services for underserved communities. Implementing microtransit comes with its own set of problems. You have to keep a lot of factors in mind. For example, coverage, productivity, ridership, and cost. Issues like if microtransit is implemented in an area, what are the destinations that people would go to? Would they be ready to pay for it? Factors like these. One data driven solution to this problem is creating a model that predicts the potential ridership of an area by taking into account demographic features of those areas. For example, the population density, median age, median income, type of employment of the people in those areas, factors like these. That way, our model might be able to figure out if an area would be good to implement microtransit or not, depending on the predicted ridership.
A factor that can influence ridership in an area is how frequently a bus services that area. Because of this, it is important for us to identify areas that are well served and areas that are underserved. To start this process, we looked at where the ridership existed in the current service area and made a density estimate out of that. Next, we filtered out the areas that had too much ridership to be considered underserved. Then, we layered on the routes and looked at the routes that had the least service frequency among them. This led us to identify certain areas we consider underserved. They are very good candidates for microtransit, and additionally, we use this categorization as a feature in our model downstream.
After finding underserved areas, we now want to get a sense of what the ridership can be if PVTA serves these areas well. For that purpose, we built an MN model that learns what kind of demographic makeup actually influences ridership. And then, when a certain set of demographic characteristics are provided to a model, it predicts the ridership the region should have based on its previous learnings. Our model actually allows us to see which features are most relevant to predicting ridership. These are just some of the topmost features from our model in the order of their relevance. The most important piece to our study is when we can see how the most relevant features for ridership vary across communities. And so, we create maps showing where a particular feature is high or where it is low. For example, these regions here, the purple colored ones, are those where there are many people who have cars and they drive alone, whereas this white region here is the region where there are lesser number of such people. Similarly, doing that for most of our top features gives us a good understanding of the kind of communities in these regions. In order to grasp information about predicted ridership and the demographics of a region, we created a dashboard which can show all the information concisely. You can also use these filters here to only see a part of the data if you wish to. Ridership follows clear trends with some features like the ones here. This particular dashboard will essentially be useful to see such trends to make judgments about whether or not the predicted ridership makes sense. As far as the future work is concerned, we can find potential hubs that currently have high outgoing or incoming demand and then using our predictive model and dashboard find if there are any rural populations around these towns that will be happy to ride microtransit if it were in place. That was an overview of our work with PVTA. For more details, please feel free to contact us. Thank you so much for watching our video.